The aim of this lesson is to introduce you to TFT displays, explain how they work, and how they communicate with microcontrollers such as the ESP32. You will learn the key concepts behind TFT display technology, its advantages for IoT applications, and how it can be used to help visualize data. As we move forward in our IoT project, the next step is to help visualize the data in a user-friendly way. One of the most common methods used for displaying data is using a TFT display, or a thin film transistor display. TFT displays are colorful, small, and capable of rendering dynamic data in real time. This makes them perfect for compact IoT projects. So, what is a TFT display? A TFT display is a type of liquid crystal display, or LCD, that uses thin film transistor technology to improve image quality. Unlike older passive matrix LCDs, which have slower refresh rates and lower contrasts, TFT displays allow for sharper images and faster updates, making them ideal for displaying real-time data. Some key characteristics of the TFT displays include the color capability. TFT displays can show full color images, usually supporting 65,000 colors or more. This is very beneficial when designing more appealing interfaces. A fast refresh rate. TFT screens update quickly, allowing them to show real-time changing data, like for our case, from sensors. The resolution of our specific TFT display is 135 by 240 pixels, which provides a decent area to display text and basic graphical data. These displays are available in various sizes, 1.4, 1.8, or even 2 inches, etc., making them ideal for portable or space-constrained projects. Some TFT displays also have touchscreen capabilities, which adds an additional layer of interactivity. For our project, we will be using the 1.14-inch TFT display attached to the ESP32 on the TTGOT display development board. The reason why we use this type of display is because it provides a clean and compact interface to showcase real-time data. Now, how do TFT displays communicate with devices? TFT displays communicate with microcontrollers through an interface known as SPI, or Serial Peripheral Interface. SPI is a fast and simple communication protocol used to transfer data from microcontrollers to peripherals and backwards. The pins used for the SPI communication with the TFT displays are MOSI, or Master Out Slave In. This pin carries data from the ESP32 to the display. MISO, or Master In Slave Out. This pin carries data from the display back to the ESP32, though it is rarely used in display communication. SCK, or the serial clock. This pin synchronizes the data transfers between the ESP32 and the TFT display. And the CS, or the chip select. This pin signals which device on the SPI bus is active for communication. In our case, the TFT ESPI library is used to facilitate the communication with the TFT display. This also helps simplify the code needed for it. As I said before, the library handles all of the low-level operations needed to interface with the display, letting us focus on how to format and display the data. Some advantages of TFT displays are enhanced visual output. TFT displays allow IoT devices to display data in color and with great detail. Sensor readings can be updated on screen immediately, offering real-time feedback. With TFT displays, you can control everything from font size to color and arrangement of data, making it possible to design a customized user interface. In this lesson, we have learned about TFT displays and their importance in IoT projects. We explained how they work, how they communicate with microcontrollers, and why we will be using the 1.14-inch TFT display. By understanding how TFT displays function and their role in real-time data visualization, you can now create more interactive and user-friendly IoT projects. As we proceed forward to the next lessons, we will dive into the more technical aspects of programming the TFT display, updating it with real sensor data, and enhancing its visual output for better user experience.